Now, it so happened in the previous problem that we had a symmetric interval, open interval, centered at 1. Now, do we always get a symmetric open interval when solving this absolute value of f of x minus L less than epsilon? Well, let's see. We can answer that in the next problem. Alright, suppose that here we have a specific epsilon equal to 1 and a given function f of x equal to x squared minus 1. And we are going to look at the limit of x squared plus 1 as x approaches 2. And we know that the limit is equal to 5 because that's just 2 squared plus 1 equal to 5. Now the question is, if we're given an epsilon equal to 1, is there a delta such that if for all x's such that the absolute value of x minus 2 is less than delta, then this will hold, that f of x minus, it's the f of x minus the limit L is less than epsilon. In this case, our epsilon is equal to 1. Okay, so step 1, we solve the inequality. So let's go ahead and solve the epsilon inequality. Okay, solve the absolute value of x squared plus 1 minus 5, that's your f of x minus L, is less than our epsilon is 1. That is equal to the absolute value of x squared minus 4 less than 1. And that's the same as x squared minus 4 is between negative 1 and 1. Okay, and now we add 4 all throughout. And what we get is that x squared is between 5 and 3. Alright, so now if we take the square root of everything, it still maintains the same order of the inequality. So now taking the square root of everything, x is now between square root of 3 and square root of 5. So from step 1, we were able to obtain an open interval from square root of 3 to square root of 5 containing our x sub 0 equal to 2. Alright, now let's look at this. Is this a symmetric open interval about 2? Well, we'll find out when we solve, when we apply our step 2, or letter B, is that we are now to find a delta that satisfies the absolute inequality x minus 2 less than delta. Alright, so if we remove the absolute value, we're saying that x minus 2 is between negative delta and delta. This is our symmetric open interval centered at 2, and if we add 2 all throughout, we get 2 minus delta, 2 plus delta. So the question is, will it match this open interval? So our question now is, if we match this up here, okay, so this is now square root of 3 and that's square root of 5. So all we have to do is solve these to match up the two. So let's say we call this delta 1 and delta 2. Alright, so then we solve this equation, so we just match them up. 2 minus delta sub 1 is equal to the square root of 3, and 2 plus delta 2 is equal to the square root of 5. Okay, so if we do this, we see that delta 1 is equal to, if it's just putting delta to the other side, it's going to be 2 minus the square root of 3. Okay, and this is approximately equal to 0.268, whereas here delta sub 2 is equal to the square root of 5 minus 2, and it turns out that delta sub 2 is approximately equal to 0.236. Okay, so we've seen here that this delta is bigger than this one. So what we do now is we choose the smaller delta as our choice of delta so that we can get an open interval that's symmetric about x sub 2 that will be contained in this open interval. If we choose delta to be square root of 5 minus 2, then for all x's such that if x minus 2 in absolute value is less than delta, then the absolute value of f of x minus 5 is less than 1.